While we are still on the topic of extracting subvectors, I want to show you a few other tricks. You can perform a conditional extraction or logical extraction, call it whatever you want. The idea is that you can extract elements from your vector that match a given condition. For example, let's say that you're measuring the voltage on the battery of your car while the car is running every 1 minute to see if the battery is healthy or if the supplied voltage is enough. A good voltage is about 14 volts or a little above 14. So you take 15 measurements over 15 minutes, one measurement on each minute. And surprise, surprise, we have an issue. You can see in the values that I have here that while most of the time the voltage is within the healthy limits, sometimes it drops dangerously low. And you want to find the voltages that are less than 14 and see how much it actually drops. So let's start writing some code. Now this is a bit long vector, so we can't see a part of it, but all of the values are between 12 and 14 point something. So we want to get the voltage that is less than 14 and we want to save it in another vector. So let's create less than 14 equals. We take our vector measured voltage and we open brackets, and here is where we are supplying our condition. And the condition is less than 14. But we are missing something. We need something to compare with 14. And this something is the vector itself. So what we have to do is just supply the vector again. This is what we need to do. We are getting the measured voltage vector and we are selecting each of the elements from the measured voltage vector that are less than 14. Let's run it and see if this is going to work. We run it and we get 12.6, 0.8, 12, 12.7, 0.5, 12. Alright, so we got all of the desired voltages. What if we want to get the voltages that are above 14? So, more than 14 equals measured voltage more than 14. Run. And we get 14.2, 14.1, 0.3, 0.7, 0.2, 0.1, and so on. All of the voltages from our main vector that are more than 14. Here we are simply supplying the relational operator that simply is going to check the values of the vector against the value that we give it here, in this case 14. In a similar way, we can extract voltages that are equal to 12. So equal to 12. Measured voltage equal to 12. Let's run it. And we get only 3 such voltages. Now, how does this actually work? If we extract the condition, and we use it on its own, we get a vector that has the exact same length as our measured voltage vector, but it has only zeros and ones. And if you look down here closely, you will see that we get a 1 by 16 logical vector, meaning that these values here are booleans. And what we are essentially saying here is, okay, take these values from the vector, so in the form of zeros and ones, but we are basically giving it a boolean vector which is produced by our condition here, and these zeros and ones are telling it which values to take and which values to skip. If we check, the fourth element must be true for this condition, so the fourth element from our vector must be less than 14, and it is. Our first 3 elements are more than 14, that's why we have zeros. Let's suppress this output and let's rerun it for the true false here, and you can see that we got the first element 14.2, we skipped the second false, no 14.1, and we got the third element and we skipped the fourth. We got only 2 elements because we have only 2 truths. Now let's move on and we can use a similar approach to get all the voltages that are less than the average voltage, for example. To do this, we first have to calculate the average voltage, and we already know how to do this. So we are going to take the sum of the vector and we are going to divide it by the length of that vector, like this, and then we are going to take less than average equals to measured voltage of measured voltage less than average voltage. Let's run it. So let's not suppress this. So our average voltage is 13.43 and all of the voltages that are less than the average voltage are right here. Alright, now let's say that you don't want to extract these values, but you want to modify them while they are still in this vector. Instead of taking them out of the vector, maybe you want to find all voltages that are less than 14 and you want to set them equal to 14. So every voltage, the 12.6, the 12, the 12.7, we want these to become 14. We can do this the following way. We can select measured voltage and we have to pass the condition here. So we're looking for voltages that are less than 14 and we want to set them equal to 14, just like that. If I run this now, let me suppress this. If I run this, you will see that our fourth element is now 14. 4, 5, 6, the sixth, also 14, 14, 14. So every voltage that was less than 14 is now equal to 14. As you can see, we have no voltages that are less than 14. This is how you can replace values in a vector. You can say, all right, I don't want these values. They are too low for me. Maybe they are not that significant and you don't want them to impact your final calculations. So you want to make them closer to your actual values. This is how you would do it. Or instead of replacing these values, you can perform some arithmetic operation on them. Following the same logic, you would still, I'm going to comment this, you would still select the same voltages, but instead of setting them equal to 14, you want to add 2 to each of these values. So the 14.6 will become 14.6, the 12 will become 14, the 12.8 will become 14.8. The way to do this is, again, simply select these voltages from the measured voltage vector, and then we have to select them again. So again, measured voltage of measured voltage less than 14, and we want to add 2 to these values. Now, how does this work? First, let's see if it's working. So let's run it. All right, so we have, again, all voltages are above 14 and our fourth is 14.6. Here we have 14, 14. All right, it's working. How does it work? First, we're saying, all right, take the elements from the measured voltage vector that are less than 14 and set them equal to, again, take the same elements and add 2 to these elements. So we are taking the elements, modifying them, and we are kind of replacing them back in the same vector. This is how we will do it if we want to perform some arithmetic modification to these values. And finally, I want to show you that you can have multiple conditions when selecting such values. Now, this will include the use of logical operators, which we haven't seen yet, but we will see them very, very shortly. The logical operators are AND, OR, NOT, XOR, and so on. But I will just show you one very simple example, just to show you that it's possible to have more than one condition. So we want to get all low voltages. So low voltage equals to measured voltage of, now here is our condition again. So we want to take all voltages that are between 12 and 14. So we want a measured voltage that is more than or equal to 12. And we want the measured voltage that is less than 14. Now here we need to use another set of brackets to separate our conditions. Like this. And if we run it, now we don't have any values in the low voltage vector because here we got rid of all low voltage values. So I'm going to remove this as well and rerun it. And there we have it, all of our voltages that are a low voltage, that are within our boundaries between 12 and 14. Instead of extracting them, if you want to remove them from your vector, this is the final thing that I'm going to show you. If you want to remove them, I'm simply going to reuse this condition like this, and I'm simply going to say equal to nothing, to empty square brackets. If I run this now, we will get our main vector, but the low voltages are no longer in that vector. Now we have 9 elements in the measured voltage vector. So if you want to remove an element from the vector, you don't want to replace it, modify it, you simply want to remove it, simply set it equal to empty square brackets like this.